Okay, everyone, thanks for joining. You're here today for our webinar between 3D Chimera and MakerBot on the topic of 3 ways to grow your business with additive manufacturing. This is the first in a series of webinars that we'll be doing, talking about the different ways that we see organizations that we work with implementing additive to not just simply have a new tool, but to actually grow their business into the future. So today we're going to have 2 folks on the call. You have myself. I'm Alex, the CEO at 3D Chimera. Many of you on the call here will know us. I'll give you guys a little introduction about our organization in a moment. We're also very excited to have Camille from MakerBot on the line. He's the Senior Manager of Channel Strategy, and he'll be giving us a really great example of how some of MakerBot's customers are using their technology to actually grow their business in very similar ways to what we'll be talking about today. Are you on the line, Camille?
Yes, I'm here, Alex, and excited to speak to everyone about how AllAccess Robotics is using Method in the 3 areas that 3D printing can really help a business grow.
Fantastic. Very good. Certainly as we go, guys, everyone on the line, if you have questions, if you have comments, please enter them into the comment box. We also have another colleague of ours, Liz, on the line. Liz will be our host today, and she'll be helping with the Q&A session at the end. So any questions you have this come in. She'll sort of combine those together and share those with us, and Camille and I will address those live on the line and be happy to try and work through anything that you guys might be trying to figure out right now. So to give you an idea of today's session, we'll start with a little introduction. We'll share these 3 big ideas on how additive can grow your business. I'll give you guys a little tour of the 3D Chimera office, show the MakerBot Method 3D printer so you guys can kind of see that without having to come down here to Miami and see it in person. And then Camille will take over and share his presentation about AllAccess. In the very end, we'll follow that up with the Q&A session. So a little bit about 3D Chimera for those of you guys who don't know us. We are based down here in Miami, Florida. We have a focus specifically on additive manufacturing and 3D scanning. So we look at that from a number of different angles. We do equipment sales. We provide engineering and design consulting for organizations who are starting to adopt the technology. We do provide 3D printing and scanning as a service, which can be really nice as you're sort of starting out with the technology and trying to decide if the investment makes sense for your organization. We try and help you guys through that process. We work closely with a lot of the materials and manufacturers of equipment that we work with, and we actually do a lot of R&D with those folks. So not just simply selling machines or using machines, we're actually actively involved in the development of them. And occasionally we take on, fun product development projects, and you'll know that as you start to work with us, many of the things that we sell at 3D Chimera are solutions or products that we've developed to help our customers be more successful with the products that are on the market. We're very proud that although we're a very small team here in Miami, we were recently recognized as one of the top 10 3D printing consulting and service companies in the United States for 2019 by Manufacturing Technology Insights. So, we do our best to really provide technical knowledge and expertise for our customers so that you guys can really find success with the technologies that you adopt. And we work with a broad range of partners out there. So on the 3D printing side, we work with a company called German RepRap, which are open material FDM style 3D printers. We work with Tech, which is an SLS 3D printer. We work, of course, with MakerBot, who's on the line today, and Tier Time as well. On the 3D scanning side, we work with HP on their 3D scanners, as well as Mantis Vision Systems. We have complementary software that works with those. So the ANSYS SpaceClaim and GeoMagic, particularly the Design X and Control X softwares, are great for doing reverse engineering with that software, and combined with the 3D scanners and printers that we sell. And then we work really closely with a lot of different material partners out there. So you'll see a lot of brands that you recognize, maybe a few that you don't if you're not heavily involved in additive, but it's really been a great aspect of our business to be able to collaborate with these guys. We're kind of in a new era of additive manufacturing today where, large organizations who are wholly dedicated onto, making super innovative materials are out there developing those materials and optimizing them to work on open material printers. So, that's going to work on your German wrap props, and it's going to work on your MakerBots. So, we're very careful to select the equipment that we have on our team to work well with the best of the best that's out there. So every day we're finding new stuff, and we'll share some of those types of materials with you guys today. So our topic today is generally focused on 3 ways to grow your business with additive. And as we see the topic today, kind of the top 3 ways that we most commonly see folks using additive is 1, for prototypes. So I'm sure a lot of you guys are familiar with that. We want to share a little bit about our perspective on that. We think it might be a little bit different and help you to kind of maybe look at things through a different lens than how people traditionally look at prototyping. We also see a lot of customers who are using additive manufacturing to develop tooling, jigs and fixtures to help their business with traditional manufacturing. So, adopting additive doesn't mean that you have to give up the way that you've always done things. It can actually supplement those things, make them better, or even open up new lines of business. So we'll share some ideas about that. And finally, is the idea of reducing inventory, right? Is it possible to use additive to produce parts on demand and actually reduce the amount of space you need for inventory, the amount of carrying costs you need for inventory? And we think the answer you'll see to that is yes. And our case study at the end today was going to touch on all 3 of these ideas. So we're very excited about that. So before we go too far, I want to start with a little bit of a poll here. So I'm going to go ahead and launch our poll right now. Be open for just a moment here. And the questions are, what is your experience with additive manufacturing? So we're just trying to get an idea of the folks who are in the session here. Are you guys beginners? Are you experts? Are you, just kind of getting started? And then which applications are the most interesting to you? So we've got prototypes, tooling, inventory. Great. So it looks like we've got a good mix of people here. Got a couple beginners, a couple experts, and a lot of interest, it looks like, on the idea of prototypes. So that's great. And we will be touching on all that stuff today. Okay, so let's start with that first topic, prototypes. So in general, the way we look at it is there's 3 common ways to get prototypes. You can do in-house 3D printing, you can outsource 3D printing, or you can do traditional manufacturing. So, traditional manufacturing is probably the most common. Most organizations out there have been doing this for years. It's kind of the way things have always been done. So, what does that look like? It's a Bridgeport machine, it's a milling machine, it's a CNC. Typically, these things require manual labor and manual programming. They usually require like a highly skilled operator. So, if your organization is large, perhaps that is, a team that you have of machinists who are there and their sole job is to, work on these pieces of equipment and program the CNCs so that parts can get made. Perhaps you're a smaller organization, you might be outsourcing that expertise to a traditional house that's doing, CNC type of work. Now, what's tricky about that is the people who program CNCs have to be super skilled, which means that, we've got to cover those costs as someone who's purchasing those services. In addition, it's a subtractive process, right? So in traditional manufacturing, we're always starting with a block of material and kind of removing material away, which means that we're effectively paying for waste material every time we buy a part. So there's a lot of hidden costs in traditional manufacturing that you might not see, but when you're buying, perhaps a large block of ABS plastic for a CNC part, for you maybe only need fine details, but that's spread out over a large area. It can be a lot of material that's wasted. It can be a lot of setup time that's required. It can be a lot of programming on the CNC. And those things drive up the turnaround time and drive up the cost of parts. So as most of you guys know who are doing this approach, prototyping is something that you really consider seriously when you're building a part. It's not something that you're going to kind of do willy-nilly. You're going to prepare drawings. You're going to prepare everything. You're going to, cross those T's and dot those I's and double check it, triple check it, because it's a major investment to get those parts. And not just in dollars, but also in time. In addition, one of the things to think about is that, in traditional manufacturing, it's kind of strange, but most of the time people order things like from the same materials every time. And that's because in the CNC or machining world, some materials are easy to work with and others are not. And the reality is that a lot of us as engineers have sort of been trained to select materials that are easy to machine, not necessarily materials that are optimal for our application. And so, we can kind of flip that on its head if we think about how we can do that with additive, right? So we think about outsourced 3D printing. That's usually like the first step that people do when they're kind of starting their journey into additive. So you can work with service bureaus that are huge or small service organizations like 3D Chimera. In all of these places, the labor costs are going to come way down. So we don't have to have, a CNC operator who went to university here to run 3D printers. But the reality of working with any service organization is that, that organization has to cover their overhead, and that is covered through service work. And so as you guys are outsourcing parts, you're effectively paying the overhead of another organization to do that. Typically, when you're outsourcing to like a big company, they're printing on these super huge industrial 3D printers, which are awesome, but they have some shortcomings. And a couple of those shortcomings are that you don't have as many material options usually, right? Because the service bureau is going to kind of pick a few that work well for them to kind of quickly turn projects. So you're kind of stuck in that same spot that you might have been where you're outsourcing or even working in-house with traditional manufacturing, where you might not be able to look at the broad array of materials out there. And a lot of times these large industrial printers require like proprietary materials. So, of course, you're working with 3D Chimera, that's a little different. We're a small team and we can be flexible and we can, work with unique materials. But you work with some of the bigger players out there, those materials are going to be proprietary. And what does that mean? That means that there's not a lot of options, but it also means they're not super cheap. So, when you run these big machines, they work fantastic and they're very reliable, but the raw material costs are high and those costs get passed on to the customer when those parts are outsourced. So for those of you guys that are outsourcing 3D printing today, you likely know that it's way faster than traditional manufacturing, which is awesome, right? So you're cutting your turnaround time from maybe 2 weeks down to like maybe 1.5 weeks, something like that, which is great. And usually the print time is way faster, but you're dealing with the logistics and the shipping and all that sort of stuff. And it's usually a bit cheaper than traditional manufacturing. At least you're not starting with that solid block of material. You're able to only use the material that you need. So even if those materials are a little more expensive, they tend to be less expensive than buying like a huge block of material and kind of cutting it away. So there are definitely advantages to outsource 3D printing, but there is another way, and that way is the way that we're usually the most excited about, and that's the idea of in-house 3D printing. So this would be where you probably dip your toe into the water with outsourcing. You figure out the type of technology you'd like to bring in. With in-house 3D printing, you can bring in a printer that meets your needs. So here across the screen, we have a pretty big variety of printers. So on the left side, we have the German RepRap X500. That's going to be a high temperature material 3D printer. This is where you're going to print your ABS, your polycarbonates, your peaks, your Ultems. It's got a very large build volume. So this is a super flexible system for high temperature materials. In the center, you have the Centratec S2 3D printer. This is going to be an SLS 3D printer. So you're going to get the advantages of nylon or TPE powders, very fine details, and a pretty big volume here as well. And then on the right, you've got the MakerBot Method X and Method. Now these printers are fantastic. In the Method system, you're effectively getting the quality of an industrial 3D printer, but just shrunken down on a smaller scale. As some of you guys might know, MakerBot was recently acquired by Stratasys, and so lots of that technology is actually implemented into the system. We're very excited about that today, and I'm sure that Camille will be able to highlight a number of different ways that technology might be able to help you guys in the future. So, as we look here specifically at the idea of in-house 3D printing, there's some obvious advantages. Certainly, it's easily operated by you. You're the designer of the part. So what does that mean? That means you don't have to make a technical drawing. There's no additional information to communicate because you're effectively setting the part up and hitting print. And that amount of time is, usually a minute or two. You're not spending hours or days preparing that information. You probably spend more time making a technical drawing to send to a traditional manufacturer than you do just setting a part up for 3D print. You get all the advantages of outsourcing, right? So you're getting all that quality, all that that benefit of having just building the parts out of the materials you need of additive, with a lot of those negative costs, carrying the overhead of another organization, completely off the table. You also have the added advantage of being able to choose a material that's the best fit for your application. So, if you're working on something and you need a special grade of, carbon fiber reinforced PEC material, no problem. With these types of machines, you can select that and you can run that on your 3D printer. You don't have to, be at the requirements of what a service bureau might be able to offer. There's another hidden benefit there, and that is that the reality is that in the open material market, materials are significantly less expensive. So you're going to be able to actually save money, not just by using only the material that you need, but actually only having to pay, a fraction of what even the service bureaus are paying for their raw materials. So it can really be a huge advantage when you start to look down at the numbers for doing in-house 3D printing. So I just wanted to share with you guys a little bit of examples of, what 3D printed parts can look like. So here, these are all just detailed parts that came off of the SLS 3D printers from Sintertech. So these are going to be your PA12 parts. You can see really fine details here. It's a powder-based process. And then these are some examples of the types of parts you can get off of your FDM or FFF style 3D printers. These are going to be your MakerBots and your German RepRap 3D printers. So you can see the variety of parts, parts for strengths, parts for function, or parts for fit checks, parts for aesthetics. There's a lot of different stuff that you can use it for. So, as you think about how you can grow your business with prototypes, there's really two big things to think about. The first is a fast turnaround time, right? So if you can make more prototypes, that means you can iterate more. That means you can build better products, right? It also means that you're going to be faster to market and you're going to have way less design risk because you're going to have the ability to make more prototypes than just kind of that one-off prototype you might have done with traditional manufacturing. So, the big questions to look at your organization are, what is it worth to reduce risk for your company? How much would a major mistake that you find in maybe your second or third round of prototyping cost an organization if you don't catch it, right? And additive can solve those types of problems, can reduce that risk. And sometimes that's difficult to quantify, but, try and think about that. For your organization, have you ever had a time where, a prototype could have maybe found a mistake before it happened? And we've had customers who have been able to identify problems that would have cost them, an entire, containers worth of materials ordered from overseas that would have had them scrapped. They catch those things early in the prototyping stage so that when they get parts back, they're exactly what they expect. And, of course, if you're thinking about time to market, what is the value of being first to market in your industry? If you're working on something new, you can iterate faster. Your competitors are taking weeks to build their prototypes, and you're building them overnight. You're going to hit the market faster, and that's going to give you a larger share of the market right from the get-go. So, think about what is that worth for your team, and would an investment in additive allow you to sort of unlock that potential? Another way to think about it is just straight lower cost, right? So you're only paying for the part material. There's no real labor involved. There's no real overhead. There's no real waste material involved. So, you're making more prototypes, and ironically, they're costing less. So you're getting all the benefit of having more prototypes. You're not really breaking the bank either. So, what do you do with that savings, right? Do you guys take that and invest it and make more products and sell more things, develop more things? That's one way. Is that just more profit that goes to the bottom line, that helps the company grow? These are some of the things that, as you're thinking about your business and you're trying to, figure out the ROI of an investment in additive, these are the types of ideas that can often be difficult to quantify, but that we see companies tell us time and time again are the real values of bringing additive into their organization. So moving on to the next topic, let's think a little bit about tooling, right? So in tooling, You know, there's a whole variety of things. You got tooling, you got jigs, you got fixtures. You know, old school way, it's similar to how we prototype, right? Traditional manufacturing, you're going to have those long turnaround times. You're going to have high costs. There's going to be high labor involved there. And today with additive, we get all those benefits we were just talking about with prototypes, right? So fast turnaround times. We're going to have those lower costs. We're going to have low labor costs. But what's really interesting, maybe the most interesting thing, is that now we can focus on the new materials that are out there to build our products from. So, you know, carbon fiber reinforced materials, nylon reinforced materials, electrostatic discharge materials, ESD materials, materials that have super high temperature ranges or super high chemical resistivity, perhaps parts that are made of polymers that are, you know, optimal for like non-marring a surface or for protecting a surface during a check fit. So there's a lot of hidden benefits to utilizing additive, particularly additive with polymers in tooling, jigs, and fixtures that sometimes fall beneath the radar. And a lot of that's because in traditional manufacturing, you know, we send stuff out for tooling. Those tools are usually made out of steel or aluminum, and that's great. It's durable. It works well. You know, it costs a lot. It takes a lot of time. But you know, with today's technology, we can actually produce parts out of polymers and get incredible results. So, you know, opening up your mind a little bit to implementing a polymer solution with additive for a tooling application can really change the game. So, you know, here are a few examples of where you know, polymer additive manufacturing has been used to help with tooling, jigs, and fixture applications. So on the upper left here, you have a casting application. So this is where you're going to 3D print the master pattern, and then you're going to do traditional sand casting, and you're going to be able to produce a part out of metal. But instead of forming that master pattern out of, you know, a CNC component, or sometimes those are made out of like a handmade tool that then is like done with a wax form, we can actually just 3D print those parts on demand, and then we can cast our parts and get, you know, functional metal parts on the other side. So you don't have to really completely change your process. You're just simply replacing a component of that with additive. So to the right of that, we have another really interesting application, and that is for vacuum forming. So a lot of organizations use vacuum forming. It's a great technique because you know, the materials are super inexpensive, and you can get some very interesting shapes and geometries just by simply heating a sheet of plastic and sort of sucking it down. And what's really cool about additive is that we have materials that can withstand those temperature ranges of those hot sheets of plastic coming down. So, you know, maybe you don't need to fabricate that tool out of aluminum. You know, maybe, you know, I see some companies using, you know, MDF and wood, you know, that's sort of stacked up and that they're kind of hand shaping. You know, how much more precise could your vac form be if you were to design that in a computer, design that tool, and then 3D print it? And, you know, what's neat is you get to take kind of the benefit of that prototyping as well, right? So this is showing some progressions here through the design of the initial tool onto the final tool, and how the design can kind of morph and change as you go. So, you know, you can actually prototype with additive a tool, and then start making functional parts as your prototypes in-house that you otherwise, you know, have to wait to the end of the process to do. So, you know, sometimes customers come to us and say, can I 3D print, you know, this vacuum formed case? And my answer is always, why don't you 3D print the tool and keep using your vac former? You know, and that's sometimes a game changer as you start to think about the technology. And then of course you have jigs and fixtures. So, you know, anybody who works in a production environment sees these sorts of things. So, you know, on the left side on the bottom, we have kind of a holding fixture for assembling components. On the right side, we've got a fixture that's used to support a part on a CMM. These are the types of things that in, you know, the best manufacturing environments exist and have been there for years, commonly are made out of aluminum and steel. But in smaller organizations, these are the kinds of things that often are overlooked because of the time and cost required to build them. And what that means is that the workers on the line have to be super highly skilled, right? It's that one guy that knows how to do that one specific application. If we can design that complexity out of the process, it makes it easier for us to produce. It makes our process more reliable, more repeatable. And, you know, when Dave is sick, it doesn't mean the whole production line shuts down. It means that, you know, we can continue to do this process at the same efficiency that we were doing before. So, you know, the low cost of additive can open up the applications for assembly jigs and fixtures where organizations, you know, maybe they're producing them traditionally, but oftentimes the organizations we work with weren't using them at all. And so by implementing additive, they're sort of enhancing their traditional manufacturing process as well. So, it's a great way to think about modernizing your manufacturing process as we think about growing with tooling here. Tooling wears out, right? So we can replace that with low-cost parts, right? So now all of the components that we've been dealing with that have been steel and aluminum, or maybe they're made of wood or some hand fabricated stuff from back in the day, we can replace all that stuff with components that are inexpensive with additive. Excuse me. We can also produce tooling on demand. So there's no ramp up time needed. If a part breaks, we can produce a part overnight. So, think about that. If a tool was to break on the production line and the whole line shuts down, what does that lost productivity cost your company now? Right? If you lose a day of productivity, it's usually not the cost of the part. The cost of the part is irrelevant. What I've seen with my customers is when, a tool breaks down, they will expedite that, they will rush order that, they will overnight that part because they're losing thousands of dollars an hour, right? Because that part doesn't exist. If you can produce that part on demand, you can get it the same day, the next day. What is that worth? It could be worth huge amounts of value to your organization. In old tooling, often we have workarounds because there's no easy way to reproduce it. So, you have a tool, but there's something that you've kind of built by hand that kind of works with it, and it's not super efficient, but it gets the job done. With additive, we can actually build the ideal tool. We don't have to kind of compromise and use what we've got. The ability to produce parts is now inexpensive and quick. There's also another big idea, which I haven't even really touched on yet, which is the idea of mass customization. So by now, I think most of us have heard of the story of Invisalign, but it's such a great application when we think about tooling, right? So the way that they do this is they're actually taking a digital impression of your teeth and they're creating a mold for each movement of your tooth, and then they're pulling a vac form over that, and that's how they create those clear aligners. So as we think about additive manufacturing and making customized tooling for traditional end-use parts, holy cow, what can mass customization do for your business? Can you open up a totally new market? Can you offer new products that maybe your customers have been asking for, but that were just prohibitively expensive before we had access to additive technologies to quickly and inexpensively produce customized parts? So, it's a really cool and sort of hidden benefit of additive. And then finally, the idea of using additive to reduce inventory. So, traditional warehouse, if you guys are working in a company that has products, and I'm sure you do, everybody's got a room that looks like this, right? It's shelves, it's bins, it's bags, it's labels, it's confusing, it's expensive, it's a large amount of square footage. And what if we can replace that with the idea of just-in-time manufacturing? Customer orders a part, we make it and send it to them next day. You can't get much more efficient than that. That means that we eliminate holding costs, we eliminate inventory costs, we eliminate even square footage costs, warehouse space, right? So, of course, it allows us to free up cash, right? So all those carrying costs are gone, right? We're just producing parts with additive, which could actually be less expensive than even some traditional manufacturing. What could that cash flow do for your business? Our organization, we're a small business, right? What matters to us is cash flow. That's how we survive. A lot of businesses operate like that. If you can increase your cash flow, could that help your business? Could you have that cash available to use for other things, to invest in other ways, so it doesn't have to get invested in your inventory that's sitting on the shelf that maybe one day will come back to you? Or can you free up storage space, right? If you can get rid of all those shelves, but can you increase your production on your productivity on your production line? What is that worth? What is a square foot of productivity worth for your organization? So these are some of the big picture ideas that we like to have folks think about as you're kind of considering bringing in additive. Hopefully these 3 different ways can really help you guys to open your mind and see perhaps some unique ways that the additive might help you guys grow. So what I'd like to do now is just give you guys a quick demo and tour of our office, and then I'll flip things over to Camille. So if you have any questions, this is a great time to type those in. I'm actually going to grab my laptop and walk you around our office here a little bit. All right, so hopefully you guys can still see me here. So for those of you who have been down to our Miami office, this will look familiar. Just want to bring you guys out here into our our main entranceway. So this is what you see when you walk in, not me exactly, but the whole place. So over here, we've got our Syntratech 3D printers. So these are going to be the Syntratech SLS 3D printers. We got 2 of them here. These are a PA12 and a TPE dedicated system. We got all sorts of really innovative and interesting sample parts here. So here's a lot of SLS parts, all sorts of detailed parts and applications. Here's a lot of FDM parts over here that you can start to see there. We've got one of the new Syntratech, there we go, Syntratech S2 printers over here, which we are super excited about. So if you're looking to do large scale SLS, we've got that in-house. Back here, we have some of our German RepRap 3D printers. For those of you guys who've been on some of our webinars in the past, you've probably seen me go into the back. We're not going to do that today, but we've got the giant printers, the X500 and X1000 as well. Then up here is the newest addition to our team. This is the MakerBot Method X. So I wanted to show you guys this in person. I know that Camille will be giving us a little bit of a tour of it digitally, but it's always nice to see in person. I wanted to show you guys some parts here. This technology is really, really cool. So, we're still producing FDM parts like we traditionally have done with a lot of our printers. But what's unique about this system is that it has an incredible ability to produce support, right? So for those of you guys that are familiar with additive and have maybe worked with Stratasys machines in the past, this will look familiar to you, these types of complex support structures that dissolve out. This is actually the same dissolvable support that's used on the Stratasys machine. So if you've got a Dimension 3D printer or you've got a Fortis 3D printer and you guys are dissolving support out of that, the SR30 material, same thing runs on this guy, right? So from something like this to something like this, the surface finish is incredible. The quality is incredible. You're going to find that it's going to be your go-to 3D printer. Even we were surprised. We were excited about this machine. When we brought it in, it's become our go-to machine. We use it for projects all the time. You can see here, this is a Raspberry Pi case that we worked on for a customer. All sorts of fun stuff that can be done with this technology. Threaded components that have to go together, nest together. So all sorts of good stuff. The machines themselves are pretty awesome. You got a touchscreen display here, super high resolution, easy to navigate, walks you through the whole process. And there's some pretty cool hidden features here. So there's material bays in here that are actually sealed to the environment. So, we're down here in Miami, it's highly humid. This keeps the materials dry, which you guys probably know from some of our previous talks is super critical depending on the materials that you're working with. The second bay here is actually used, this is the support material. So you've got support material built right into the system. Inside here, there's all sorts of like hidden amazingness. I'm sure that Camille will touch on some of it. But like the nozzles kind of move out of the way of each other. There's this like amazing circulated chamber inside, which not many other 3D printers can do because of the patents from Stratasys. Has this pretty cool removable build plate, which has got like it's held on with magnets and a spring steel. So like it's like all the things that you would expect. It's connected like to the network, and it's got a camera inside of it, and it's surprisingly well designed, and it's absolutely designed for the manufacturing environment. So if you guys are looking to dip your toe in the water, it's something that we recommend checking out, and hopefully we can learn a little bit more about that and about a similar application here with Camille. So I'm going to actually flip over control to him in a moment here and let him share a little bit about AllAccess. All right, Camille, I'm flipping it over and making you the host.
Thank you, Alex. Awesome. And I'll say hi to everyone. Hello, everyone from Brooklyn. What a great first part of the webinar. Thank you, Alex, for giving us an overview on how businesses are taking advantage of 3D printing to improve overall. So this is the perfect live example when Alex and I were talking about how businesses are improving with 3D printing of a company that has improved thanks to 3D printing in all three of those key areas. So first things first, I'm going to give you an overview of who AllAccess Robotics is and how they came about. I'll give you a quick overview of who MakerBot is. Then we'll go into the value proposition of Method as a product so that you understand for AllAccess Robotics why this technology was key in making them successful in those 3 key areas. And we'll close things out with some Q&A. So who is AllAccess Robotics? So AllAccess Robotics actually started out as AllAccess Machine. And basically, they were looking to be or implement the best-in-class machine shop technology. So they had 5, 9, 11 access CNC machines with the goal of creating a part in one machine cycle. And over time, through continuous improvement, they kind of hit a wall where, because of their limited workforce and floor space, they weren't able to utilize 10 hours out of the workday. So they started exploring how they could utilize a full workday and started playing with collaborative robots. And they automated a variety of processes that they had internally to the point where they were so good and so successful at automation internally in their machine shop that they created a new business venture called AllAccess Robotics. So the objective of AllAccess Robotics is automation. And automation results in better quality due to the discipline required to implement that automation. And it really removes the uncertainty and the variability that's associated with manual labor. So that's pretty much AllAccess Robotics in a nutshell. Now let's talk a little bit about MakerBot. So MakerBot was one of the first companies to put desktop 3D printing on the map. It started out in 2009, and as you can see, it was very much a hobbyist slash tinkers type of technology. It was a kit made out of balsa wood that you had to assemble yourself, and for the first few years, that's really what MakerBot was just a tool that enthusiasts in the industry were using. And over time, we improved our technology to get incrementally better and we created the first mass-produced desktop 3D printer in the Replicator 2 in 2013. And this is the printer that really put MakerBot out on the map. And as Alex mentioned, the largest 3D printing company, the company that invented fused deposition modeling, the type of additive 3D printing that MakerBot uses, Stratasys, they acquired us in 2013. Soon after the acquisition, we already had products in development that we launched, which were the Replicator Z18, the 5th generation, the Mini, and the Replicator Plus. And with the partnership of Stratasys, over those 5 years, we were developing the next generation of 3D printers. And that's Method and Method X, which is the solution that Alex shared with you today that we're very excited about because of the 21 industrial patents that we're leveraging from Stratasys. So Method X is the printer that I'm going to be showcasing in this presentation. It's the one that AllAccess Robotics is heavily using throughout their process. So Method X is bridging the gap between desktop printers that MakerBot had been creating in the past and the industrial 3D printers that Stratasys have had all along. One of the main patents, one of the 21 patents that we're leveraging from our parent company is a circulating heated chamber. So what is the value of a circulating heated chamber for the end customer? So basically, there's consistent heat throughout the entire printing process. Most 3D printers that are out on the market that do not have access to this patent, when printing in plastic, the most important component to have control of is heat. And the way that they try and control heat is by having a heated build plate, which is great for the first few layers of the print. But as the object is being built, the layers that move away from the heated plate no longer have that consistent heat. And because of that, you'll just see shrinking, warping, and curling. It's material science. By having a circulating heated chamber, we're controlling the rate at which the part cools. And what the value is for you as a customer is a part that's dimensionally accurate. That means that when the individual has a design in CAD in their software, it meets their measurements once it's 3D printed. It doesn't shrink very much. And that tolerance is plus or minus 0.2 millimeters, which is what industrial 3D printers today, the Stratasys units, that's around the capabilities that they have, but at a much more affordable price point, a more accessible price point. Another key feature that Alex mentioned is soluble support material. This is where we're also leveraging our parent company, Stratasys. We're using their soluble support material, which is called SR30. And it just has superior layer adhesion to the main material being used in industry today, which is ABS. Outside of that, Method has gone through unprecedented testing. Since MakerBot has been known as more of a hobbyist technology or a printer that's being used in schools and in K through 12, one of the things that we absolutely needed to do when launching this product is showing that this is a tool that's being used by professionals. And we went through a very rigorous testing process. Over 300 hours, over hundreds of 3D printers was tested before going to market with the Method platform. The Method platform has two printers. The main difference between the two printers are Method has a 60-degree chamber, while Method X has a 100-degree chamber. And what that does for you as a customer, it's just a difference in the materials that you can use. So Method is optimized for PLA, PETG, tough, PVA, and nylon, whereas Method X can do all of those materials plus ABS, ASA, and has a variety of other materials that we'll be able to do that require more heat. But we're not limiting customers to those materials. One of the main things that Alex was talking about that's very important is we're an open material platform. So we allow customers to run any third-party material that they would like through this platform as long as it's able to print within our printing parameters. So a 60-degree chamber for Method, a 100-degree chamber for Method X, and extruders that can reach up to 300 degrees. So now let's get into the meat and potatoes of this presentation, how this platform is being used with AllAccess Robotics. And they were using it for prototyping, specifically to create parts that they put on their robots, so end-of-arm effectors. They used it for a variety of different jigs and fixtures, specifically their CMM fixturing, as well as a variety of other jigs and fixtures in their shop. So hold on one second. So the key part that made AllAccess Robotics inquire about Method is they were looking to create an end-of-arm effector that was going to sand steel. What AllAccess Robotics is all about is automating processes that are very laborious, that don't create the best working environment for the machine operator or the person that needs to do that job. And sanding steel with brute force and the particulates of those shards of steel being in the air isn't the best working environment for that, that individual. So they decided to create an end-of-arm effector that could do that process to automate, and for that individual instead to learn the skill of figuring out exactly how to automate that process using this part. So when thinking of this dual grit sander, this was the design that they came up with. And looking at this is going to be a very difficult part to machine. It would probably need to be machined in 2 or 3 parts and welded together. So they started exploring 3D printing as a solution to potentially make this part. And they did a very quick cost analysis of doing it with their in-house CNC versus using the MakerBot Method X. The main differences is with their CNC machine, they would have to take a machine out of production. They would have to take one of their best machinists to figure out the CAM software. They would have to spend a large amount of time preparing the tool, and then they would have to run the part. They estimated that it would cost them a little over $3,600 just to make and weld this part. Whereas on Method X, preparing the part to be 3D printed only took about 5 minutes. So they chose their printing parameters and just hit print. Material preparation or preparing the printer was minimal as well. All they needed to do was load the material into the printer, and the printer took 44 hours to print the part as well as dissolve away the support material. So all of this was being done without a machine having to be taken out of production, and the overall material cost of the part was $110. So within a couple of parts that they would make on Method X versus using their in-house CNC, they would get a return on their investment. The reason why Method was the best solution in terms of all the 3D printers that are out on the market was because of the part dimensional accuracy that I mentioned earlier that they're able to achieve thanks to the circulating heated chamber. So that means that they didn't need to machine the part in any way, shape, or form for it to fit on their end of arm effector. They didn't need to machine any holes or anything like that. There's an internal cavity inside the part that requires SR30 support material, and without SR30 support material, they wouldn't have been able to create that vacuum to be able to suck out the shards of aluminum when going through the sanding process. So that's how AllAccess Robotics used Method X to create this particular end-of-arm tool to automate this process. Now, AllAccess Robotics didn't stop there. Now that they found this first application to use 3D printing, they started exploring a variety of other applications that 3D printing could help them in their process. So the next application that they looked at was another custom end-of-arm effector, specifically for this gripper tool. So what they found is sometimes the standard gripper, the fingers, don't have enough friction to pick up the parts. So in this case, they were able to design a better part or a better end-of-arm tool to be able to pick up these pieces. But where they saw the most value is a lot of these fingers experience a large amount of wear. And instead of having to keep inventory of replacement parts, they could simply print parts on demand whenever the fingers wore out. Furthermore, what they loved about the Method X is their ability to use third-party materials. They have a wide range of materials that they could use outside of ABS, things that are carbon or glass reinforced that do very well with impact and wear. So that's how they were using it for picking tools. Another really key application was with this fixture for a laser marking application. So previously to having the MakerBot in-house, they were simply just doing this application one at a time. And they realized that with Method X, they could create a fixture that allows them to do 10 at a time, which for them was huge. A 10x in productivity is fantastic. But the reason why Method X was the best solution for them in this application has to do with part dimensional accuracy. They really needed this fixture to be precise because it allows them to precisely locate each latch. Without that, they wouldn't be able to do this application repeatedly. The last application, well, not the last, but one of the last that I'm going to speak about is with their CMM fixtures. So AllAccess Robotics considers themselves to be a low volume, high mix shop. So they were really struggling to think of creative ways to hold parts for their CMM machine. And Method X allowed them on demand to be able to design holding fixtures for their CMM machine. Now, over the past year, AllAccess Robotics have been using 3D printing for so many different fixturing applications, as well as jigs, that it's opening up a whole new business segment for them where they're starting to do jigs and fixtures for other machine shops. So I want to pause there, and I'm going to give control back over to Alex. But in a nutshell, this is a really good example of a company that started using 3D printing for a particular application. That application was prototyping. They wanted to prototype that dual grit sander. And then very quickly after implementing the technology, their engineers understood this new tool that they had at their fingertips that will allow them to design and produce parts on demand for a variety of other areas in their machine shop. So I'm going to go ahead and give Alex control of the presentation. There you go, Alex.
Okay, perfect. Very good. So I think at this point, what would make the most sense would be to open this up for any questions that might be out there. So Liz, I know you've been gathering questions throughout the presentation here. Do you have any that we might be able to address?
Yeah, thanks, Alex, and thanks, Camille, for all of the groundwork you've laid. So I've got a couple of questions that have come in, and I'm going to throw them over to you guys now. So I've had a few that are around the variety of materials that this printer can print. I know 3D Chimera refers to that as open materials. So can one of you just give a brief overview of what materials are compatible with the Method X machine?
Absolutely.
Yeah, that's a great question.
Camille, why don't you take that one?
You want to start, Alex?
Yeah, sure. We'll let you go.
So as I mentioned, MakerBot makes a variety of materials. We make our own PLA, our own tough material, PETG, our own nylon, ABS, and ASA, but there are a variety of third-party materials that are compatible with our platform. So any of those based materials infused with something else to make a composite. So for example, a lot of very popular composites that are out on the market right now are composites that have chopped carbon fiber, chopped glass. So you could do one of the materials that 3D Chimera represents is a company called Chimera, and they have a variety of really, really good chopped carbon fiber materials that you could run in the printer, like a chopped carbon fiber ABS. Other composites are things like flame retardant or ESD materials, and same thing. We have the majority of the base materials that most companies will use to meet their applications, and those composites can be found from third parties and run on Method and Method X. And then Alex, if you want to add to that, since you have a really good array of material expertise.
Yeah, no, I think that was a good summary. I mean, I know that a lot of our customers are really drawn specifically to the Method X, ironically, for its ability to produce ABS parts consistently. You know, on most of the open material 3D printers out there, you can produce ABS parts easily, but you have to do a lot of understanding of that material, right? So you're making sure that you've got the right preparation on the build plate. You're making sure you've done everything to insulate the chamber. And usually you have to manually scale the part to a certain scale. On the Method, none of that is an issue. When you hit print, you're going to get a part that comes out that's going to be super dimensionally accurate. And we're seeing a lot of folks, interestingly, who are really gravitating towards the Method 3D printer. They, of course, are interested in the variety of materials, but that ABS material, especially when paired with that dissolvable support, is really a crazy winning combination.
Great, thanks, guys. So speaking to materials, I've got one about, you know, this dissolvable support that Method X can use. One, what is it dissolvable in?
Sure. So
you want to take that question since since you have a great solution for that?
Yeah, absolutely. So it dissolves basically in like a light chemical bath. For anybody who's used a Stratasys machine before, it's basically like warm water that's kind of got a turbulent flow to it. And then there's a chemical in there that dissolves out this support. There's a couple different ways that you can do that. So Stratasys users probably have some like tablets or things that they mix into the water, and you can use that. We offer those as well. But we've actually identified a company that we're just starting to work with who has this like liquid that you can pour in, and it really speeds up the dissolving process. So the key is if you're using a Stratasys machine, you've already got all the equipment that you need. And if you don't, we have a solution for that as well that you can add into the system and kind of have a complete package, which will basically be this tank that effectively is water. You drop your parts in there, and your dissolvable support, depending on your part, is going to dissolve out anywhere from maybe an hour to maybe up to 6 hours. But it's really, really fast compared to what folks I think have been historically used to. So it's a totally non-touch process. So once you drop it in there, like you drop something like this in there, there's no other work. You put it in, you go do your work, you come back, an hour later, and that's all gone, and you got a part that looks like this.
Yeah, and to add to that,
Great.
For those that don't want to invest in a wash tank, you won't be left empty-handed. As an alternative, you can use breakaway support material. So that's support material that's made in the same material as the model that you can break away. Moreover, with the lower temp plastics, your nylons, your PVA, your PLA, your tough, and your PETG, you can use a soluble support material called PVA that just simply dissolves in water. So for those of you who might want to get started but don't want to make an investment in a wash tank just yet, you are still able to use this platform.
Mm-hmm. Yeah, good point.
Great
point.
Thanks, guys.
Liz, we're kind of rounding out on time here. Maybe one more question?
Yeah, sure. So I think the last question that we'll be able to get to, and we can follow up with everybody offline as need be, is discussing how MakerBot is supporting this new Method X and Method printer from a technical support position.
Oh, that's a good question. That's actually one of my my favorite questions. So, and I'll let Camille expand on this a little bit, but I'll give you guys my take on it. So, MakerBot has this incredible support plan available, which basically, when you make your investment in the support plan, it's going to cover the printer for 3 years. If they can't fix whatever issue you've got on that printer on a phone call, they're going to send you out a new machine and swap that out for you. Honestly, I think we've been in business now maybe 7 years. I've never seen anything like this from any other 3D printer manufacturer. I think it underscores the confidence that MakerBot has in the quality of their machines, and also their commitment to customer service here in making sure that their industrial customers find success. But Camille, do you have anything to add to that?
I think you really nailed it on the head. The value proposition of this product is really no tinkering involved. We want this to be a tool, and for engineers never to spend their time tinkering with the printer and just utilizing it to improve their business. So What I like about working with 3D Chimera is your expertise in being able to help customers with any of their needs. But on that end, we don't want you to have to deal with that either. We'll be able to support all the printers over the phone. And as Alex mentioned, if we're not able to resolve the problem the customer is having, we'll swap it out with a new one.
Yeah, that's pretty cool.
Extraordinary.
It is pretty cool, yeah. So on the screen here, I've got my information. That's my personal email address and my direct line. If you guys have any questions about anything that we talked about today, if you think that maybe some version of this presentation would be valuable for us to share with your team, I'd be happy to do a private session with you guys, maybe a lunch and learn, whatever makes sense for you and for your team. We hope that today was valuable, and that as you guys think about adopting additive and implementing additive in your organization, that you might be able to take advantage of the techniques that we've talked about today. So thank you all very much. We appreciate your time. And Camille, thank you for coming on the line here. I know that you're a busy dude, and you know, your input was really invaluable today. So thank you again for that, and Liz as well. We appreciate it.
Yeah. Thank you for having me, and sorry that the fire alarm went off in my building right in the middle of the presentation.
Well, we were wondering what that was. All right, well, hopefully everybody's okay there. Maybe you should go check that out. On that note, I think we'll close it out.
It was a false alarm, false alarm.
All right.
All right, good.
Bye, all.
All right, thank you, everybody. Bye-bye.
Bye.